Okay, everybody. Look, thank you for joining. I know we've got 9 o'clock lectures, so yes, can be hard. I thought I'd just say welcome, and we're not going to have a huge lecture today. I don't think so. Sometimes I do waffle on, but what I want to go through today is a little bit of the view site, so we can then look at the timetable and talk about, kind of how we're going to run this unit. We'll kind of run it in a hybrid mode. I'm happy, there's a couple of things really. We're doing an online lecture now. When we don't have pracs, the idea really is we'll do an online lecture, but happy to run it in person if you guys as a group, it's a relatively small group, I think about 13 or 15, want to do it in person, very happy to do it. We've got a lecture theatre booked. But the reality will be when we do have pracs and we're on campus and that sort of thing, we'll run the lecture live during those weeks, and then move pretty much straight to the practicals. Basically 9 to 11, the lecture, 12 to 2 will be the practicals on those weeks. That's the kind of idea. We ran it last year, but very happy to, if you want to come to campus, we can do it that way. But definitely those weeks that we will have to be on campus and have practicals, we'll run the lecture that way, in definitely face-to-face. So let's give it a week or two and see how we go, but certainly send your feedback if you'd rather in person totally. We can do it that way as well. Have you guys got any questions before we kind of jump in? Today's lecture is going to be, we'll just go through the view site and we'll do, I think, about a 15-slide lecture type thing, just introducing the topic, and we'll go from there. But before we get started, have you guys got any questions? All good? All right, let's have a look at the view site. Here we go again. Let me get off that. Let me jump back to Zoom. Screen 2. Okay, so this is pretty much what you'll see when you log in. The welcome, kind of, I guess the general information. You can see when the times are for the lectures and pracs. What I will definitely say is that, week to week, we'll notify, I'll send you the notification at the beginning of the week where the pracs are, where the lectures are, those sort of things. But in general, when we go through the timetable, you can get it, you can gather, if we do have a prac, it's in general, we'll have a lecture face-to-face. If we don't, then we'll do an online lecture like this. Okay, so unit learning outcomes, subject learning outcomes. The learning guide is here, and I've extracted the timetable as well as the assessments, and we can go through the assessments. Assessment 1 will be quizzes. There'll be regular online quizzes that you can do at home, and they'll essentially be just checkpoints along the way. There'll be, I think, 3 or 4 of them. We'll go through that, and they're worth about 20 minutes. Can you guys go on mute? I think we're getting a bit of feedback there. Assessment 2 is essentially a case study that you guys are going to do and present. It's pretty much like a 3-minute thesis, one or 2 slides, and they'll be based on when we start in a couple of weeks. We'll actually be in the computer labs doing GIS and remote sensing and learning how to do it. And essentially you'll be able to do, based on that assessment, you'll be able to do an individual project, essentially displaying your capabilities, what you've learned, from doing the GIS and remote sensing things. And you'll get that as we go. We'll have, 2 weeks in the labs doing it. The good thing about it is we're going to use programs that you can use at home, so you can actually learn how to do it and actually run programs and develop ask a question, essentially then use the skills with GIS and or remote sensing to actually and attempt to answer a question and then present it. So it's only only 3 minutes or so. The idea will be still working out whether we'll do it. So it'll be online in week 5 presentation. There's a possibility, depending on your internet connection, those sort of things, where we can either do it live and share your screen, or you can record it and send it through. So we'll work out those. We can have hybrid modes for doing that as well. The other thing will be the assessment 3 is your major report. These next 2, assessment 3 and 4, are around data collection and data analysis around air quality and water quality. And so they're later in semester, so pretty much around, so with air quality, collect the data before mid-semester break, the report is due after. Water quality will be pretty much the last thing that you do, and that is associated actually with assessment 5. So you'll be working with Ian Wright, and part of it, one of it will come together to go through the data as a group. You'll do a small presentation which will help guide you getting feedback to actually do the report, the major report there. So they're the 2 major reports that you need to do. This is there's 2 presentations. One is directly related to the water quality report, group presentation to get feedback. It really is important just so they can help guide your report. Assessment 2 is an individual presentation that'll be done online, like a 3-minute presentation, where you'll actually present a case study from what you've learned, and quizzes throughout semester. All right, so this is where we are. We're in week 1, so we'll do the initial lecture. You see the next couple of weeks, we have no pracs, but we do start in week 3 and 4 to do the remote sensing work. And you can see you've got in week 5, during the prac session, we'll have, pretty much the presentation mode for that. There will be some quizzes throughout here. You can see how many we've got this year, 3 quizzes. And basically it's checkpoints. So it'll essentially be, quiz here will be based on the material over the first couple of weeks. We'll tell you exactly which weeks that it's based on. It's based on the lecture material. Same thing once we get down here. This one is in the mid-semester break. It'll be open before, so you'll just give you some time to do that. The other thing too is that we've got a lot of there's a lot of stuff that we can't do. Like environmental monitoring and assessment. It'd be great if this was a year-long thing, because we could do a huge amount as well. But we've got a whole suite of these online modules and lectures and that sort of stuff for case studies for you to kind of go through yourself as well. So, they're not going to be quizzable or anything like that. There's no in that, but it really does, give you case studies like the varroa mite, the stuff that we're doing here as part of that. If you've heard that with the bees being infected now that it's in. So we're right at the forefront of that. And so we've got some, case studies in that, things around fire as well. And you can then see, we've got it. So just going through the pracs, there's the air quality prac, which then relates to the air quality report. So that's due straight after the mid-semester break. So you essentially have about 3 weeks to do that as well. We then jump into the water quality sampling with Ian. And so there's a couple, so within these, we'll have, you can see there's student presentations here. So 2 weeks of sampling. That one's in the field here. That one is in the lab the week after. So essentially taking back the water bugs and invertebrates for sorting and identification. Presentations, then that's to help you get a little bit of feedback, and then your report's due the week after as well. The other things, there's a few things in here that where I'd almost call them evolving pracs. And even of this morning, I've been contacting an expert in the field about using drones and drone sampling and that sort of thing. That isn't actually in here at the moment, but it potentially will be. So these things might change a bit, where we'll go off and learn how to use drones for remote sensing and that sort of thing. So I'll update you with that. We'll see where they fit in. They may replace something in there, some of these pracks that aren't directly related to, the reports and that sort of thing. So it's a moving feast. And so, basically what I'm trying to look for is stuff, real innovative stuff in remote sensing, in environmental sampling and assessment. So these cutting edge technology. The problem is it would be great if it was here, but we can't actually fly drones on this campus because we're so close to the airport. So we're trying to work out a spot where we can all get to and actually be able to do it. So this may change. It may be an added thing that we can do it a period of time that could work for everybody. But basically, I'm just trying to get as much in here as we can so that you can sample and develop some skills, at least the basic skills and knowledge around it. One that we have added, this one again is still to confirm time. Associate Professor Cameron Webb, who's from Sydney Uni, but also New South Wales Health. He's the expert, the guru in mosquito-borne disease in research. And essentially his work, so we have all these monitoring sites. So he's set up all these monitoring sites throughout New South Wales for monitoring mosquitoes and actually, low levels of mosquitoes, particularly around disease and human disease like Ross River fever and a whole range of that. We're working out, and it looks like it'll be in this period. We'll be at Bicentennial Park at one of his monitoring sites, but also there's who give us a lecture, a talk about what we do, and we can see how that work is actually done there. So that's a new one to be added. And we're just waiting on confirmation on date and time because he may actually be up at Ballina. He's up at Ballina at the moment, doing sampling with that. So just confirming that. We've got a couple of weeks in here where we can, we've got an empty week here. So we'll confirm those sort of things. And any changes to this, I'll let you know. So I'll let you know if there's, well in advance. So it won't be a week out or that sort of thing as well. Okay, so you can see the kind of the presentations, and I'll just jump. I just want to kind of jump over the learning modules. I think there's probably around three main themes, particularly in environmental monitoring, and you'll kind of see them, water, land, and biological and air as well. So I kind of have these symbols going. Some weeks I forget to put them in, but it kind of says, right, this is what we're covering as we go through it. We have I call it a textbook, but it's not official. You can actually download this officially from the library link. And so we will not every week refer to, say, readings from the textbook, but where it's important, we'll actually, guide you through, and you can see the first land module when we're talking about this. You can see this is now open. This will show you, which bits of the textbooks we're generally referring to. So what I want you to see is any lectures that we do, think about them as probably more an abstract, as in to start you off rather than be the end point of doing readings and that sort of thing. So what my expectation is that you'll come to the lecture. You can do a little bit. There's potentially some pre-readings or videos to watch, but then there'll be a lot of follow-up that will provide as well. So, there'll be things that we won't actually do too much on, but we'll touch on, but then you can delve deeper into, aspects of it through here as well. So, I'm not going to stand here and talk about, all this stuff. We'll get really bored with it. So you can actually delve deeper into it and see the lecture really as that, okay, this is what we're covering. Different aspects, you can delve deeper into the textbooks, videos, and even extra lectures and things like that we can provide as well. Okay. So the only other thing at this point, you'll get announcements. Every announcement that I'll do, I'll click the box for an email to come out as well. So you'll get those. You'll get those weekly announcements of where we are, where we're supposed to be, those sort of things. And the other aspects here is this is where you'll find information about the assessments for each of those. So once they start becoming available, get turned on. You'll get notification once, like the quizzes are up. I think that you get those auto notifications. I'll still let you know anyway. I think that's about it for the views site. Obviously, the learning modules will be the ones they'll be turning on weekly, pretty much the beginning of each week, or at least within 24 hours of the lecture. Sorry, I've just turned on this one this morning. I didn't realise. I thought I'd had it on, but that's okay. There's not too much today that you needed to do pre-readings or anything like that. Any questions? Cool. All right. I think we'll jump on to the material for today. Let me just again find the right stuff. This is where PowerPoint gets a little bit. Hang on. Okay, can you guys confirm you're seeing kind of just the PowerPoint slide now? Yeah?
Yep.
Thank you. So multiple screens can be I'm not sure what you're showing sometimes, which one's screen 1 and screen 2. So all right, so today we're gonna really talk about I guess more of an overview. So an overview of why environmental monitoring is important, what type of environmental monitoring is done, and then kind of the last part is actually how do you take that monitoring and make assessments, and that's essentially where we need to. That's probably the most important bit, to actually make sense of that information. All right, so environmental monitoring is the continuous and planned process of gathering data on various aspects of the environment. Okay, so that's a big overview. This encompasses environmental components such as air, water, soil, and living organisms. And by systematically collecting the data over time, we can actually start not only assess the current state of the environment, but also identify trends and potential issues. So it's really valuable information for decision-making processes, ranging from policy formulation to resource management strategies as well. There we go. So environmental monitoring plays a critical role in safeguarding the planet as well as our health and well-being. It enables early detection of issues like important pollution, deforestation issues, and climate change, and it allows for timely intervention and mitigation strategies. It also provides valuable data for when we talk about assessments. Probably the one that we all kind of know about are environmental impact assessments, which form the basis of formulating policy. And so these are essentially mandatory studies that evaluate the potential impacts of environmental consequences of proposed projects like housing or big mining adventures, those sort of things going forward before implementation. So additionally, environmental monitoring serves as a vital tool for tracking the effectiveness of implemented environmental regulations to ensure compliance. That's a big word, because compliance has legal status, and if you're not complying with the statutory regulations or those that are in the environmental impact assessment, then lack of compliance can be used to prosecute companies or people doing the wrong thing. Furthermore, it allows us to monitor and assess the success of conservation efforts and enables us to evaluate the effectiveness and adapt if necessary as well. Okay, so environmental monitoring encompasses a diverse range of activities. I think I'm a slide behind. There we go. So So here are probably the most common ones that we look at. Environmental monitoring with air quality monitoring assesses the level of various pollutants in the atmosphere, such as ozone, particulate matter, sulfur dioxide. There's water quality monitoring. And as you can see, all your reports and assessments are relating to these major types of assessment or monitoring and assessment. So basically what you're going to be given is and collecting is data for environmental monitoring and then doing assessments essentially based on that data. Water quality monitoring evaluates physical, chemical and biological characteristics of our rivers, lakes and oceans. Soil quality monitoring analyzes the physical, chemical and biological properties of soil, such as soil health and potential contamination of soil as well. And biological monitoring employs living organisms as indicators of environmental health. And changes in populations or health of specific species can signal environmental disturbances too. So kind of all of this comes together and a lot of this now we collect in isolation, but the assessment part puts this together to actually look at potential impacts, potential changes in the environment, in the physical, as well as the biological environment. All right, so next slide. Okay, so air quality monitoring. So let's go a little bit more deeper into each of these. This is crucial for assessing levels of various pollutants present in the atmosphere, including harmful gases like nitrogen dioxides, as well as fine particulate matter as well that affect our health. So we often get alerts about air quality. This is essentially those alerts are translated from data that's collected in various parts of the environment, and we have a network of air quality monitors throughout Australia, throughout the world actually, that can then trigger alerts for public health. Monitoring is typically conducted using the network of fixed stations, but we also have mobile stations as well that can go into the network. So the instrumentation continuously measures pollutant concentrations, which might be from, like I said, nitrogen dioxide, sulfur dioxides, right through to particulate matter and pollen, depending on, they can send alerts and trigger various responses as well. There are passive samplers too, which are simpler and less expensive devices and can be used to collect air quality over a longer period. Data from air quality monitoring plays a vital role in ensuring compliance of industry and compliance with the environmental regulations of reducing air pollution and safeguarding public health. All right, water quality is essential for assessing the health of our water bodies and ensuring suitable for various purposes. The comprehensive monitoring process has a whole range of physical, chemical, biological parameters such as pH, dissolved oxygen, presence of contaminants. And what you'll see, particularly with Ian's work, you'll really concentrate on the invertebrates and potentially looking at them as key indicators of environmental health within our water bodies here on campus. Soil, which Richard Thomas will talk to you about next week. Soil quality monitoring is crucial for assessing the health and sustainability of soil resources. So such as physical, chemical, as well as biological, and like the invertebrates, as well as the fungi networks. Physical properties like texture, structure influence water. Water infiltration and aeration, so which is really important. So if you've got compact soils, wrong types of soils that because of a whole range of different activities that have gone on, that can very much influence the growing properties of the use of that environment for growing plants, plants related for food, plants related for the environment as well. While chemical properties like pH and nutrient content impact plant growth and soil fertility as well, biological components focus on the presence and abundance of soil organisms, which are vital for decomposition and nutrient recycling. So by monitoring soil quality, we can assess potential contamination risks and evaluate the impact on the impact of agricultural practices and land use changes on soil health, and then look to implement strategies for soil conservation, because erosion can be a huge issue. So as well as improvement of soil quality. Lastly, but certainly as important as anything else, biological monitoring. And this is also known as biomonitoring, and it's a unique approach that employs living organisms as indicators of environmental health. The underlying principle is that changes in populations or health of specific species can serve as kind of those early warnings, early trigger points, and often integrate the effect of multiple environmental stresses. And so this provides, I guess, a more holistic picture of ecosystem health compared to the individual monitoring parameters that we talked about before. This looking for those species that potentially are early indicators of changes in those physical properties or environmental parameters are crucial, so they can actually, predict what potentially will happen in ecosystem changes and ecological changes down the track. Commonly, their use include fish species. So common species are fish, insects, birds, plants, and really what you'd say they're serving as sentinels for specific environmental conditions that are potential trigger points. So you can monitor the abundance, health, and diversity of these indicators. We can get really valuable insights on the overall health of the ecosystem and start planning for issues much earlier than waiting for the physical parameters to actually even be recorded. Like, you can be so sensitive that you can't even pick them up with equipment, and start enacting conservation measures to actually do something about it. Okay, so techniques, and we're going to look at a bunch of these techniques. So environmental monitoring encompasses a diverse range of techniques to collect and analyse data. So remote sensing, so we'll jump into that in week 3, utilises satellites and aerial photography to gather data over large geographic areas. It's these technologies have really been able to allow us to kind of monitor environmental changes like large practices in deforestation, land use changes, and coastal erosion particularly. In situ monitoring, this is directly measuring environmental parameters. So this is actually putting equipment out in the field that is actually measuring at a particular point. It provides real-time data on factors like air quality, water quality, and soil moisture. And then laboratory analysis. So samples collected in the field are often analysed in laboratories using sophisticated equipment to measure specific parameters, important pollutants and the abundance or presence of specific organisms as well. So using like eDNA techniques and things like that. The analysis provides detailed information about the composition and characteristic of the sampled environment. All right, so then again, this is an overview, and like I said, there's I've provided some more detail to delve into this aspect of it, particularly around environmental monitoring, which you can go to modelling as well. So the raw data collected through various monitoring techniques needs to be carefully analysed and then interpreted so that we can extract meaningful insights. And this process often involves statistical methods and modelling tools to identify trends, patterns, and relationships within data. For example, analysing air quality data over time can actually reveal trends in specific pollutants, while water quality may actually identify sources of contamination as well. So the crucial step in implementing the data involves drawing conclusions and inferences based on the analysis. And ultimately, these, the raw data to the data analysis to the interpretation informs decision-making processes related to policy, resource management, and conservation efforts. Okay, so that now leads us into, I guess, the processes around environmental assessment. So actually assessing, taking data and also making predictions, but also identifying, evaluating the environmental effects of proposed projects and activities. So obviously that also delves into the political environment as well. But from an environmental assessment point of view, it's a comprehensive assessment that allows informed decision-making by considering the potential impacts on various components, such as what we talked about: air, water, soil, and biodiversity measures. The primary purpose of environmental assessment is to identify, predict, and that's the big one. That's the big one actually really, going forward, and particularly the use of AI, artificial intelligence, to help decision-making as well. And we will touch on that. And you'll actually be in various assessments or various parts of in practice that we're going to use. We're actually going to encourage you to use AI to actually help with some of the remote sensing that we're going to do and that sort of thing, to actually make more sophisticated type models that can inform, have a better predictive outcomes. And we'll demonstrate some of the stuff that we did really directly from last year's class. So some of the stuff that we did has actually now been implemented, and we'll talk about those in the next few lectures once we start to the remote sensing stuff, how AI has actually helped us create predictive tools in remote sensing as well. So we're going to encourage you to use it for this, because AI is going to be really important, particularly in the predictive modes of environmental assessment. Okay, so ultimately we want to minimize the negative environmental consequences and promote sustainable development practices. That's essentially what we want to take environmental monitoring to, the assessment level, to then have outcomes that are sustainable and sustainable practices, and build upon that going forward. So by incorporating environmental considerations into planning and decision-making stages, we can strive to minimize environmental damage and ensure sustainability is achieved as populations grow, because that's ultimately the increase requirement for resources as populations grow can have very dramatic, deleterious environmental impacts. So what we need to do is actually, use environmental monitoring and assessment to inform sustainable development goals and strategies for going into the future. Got that one in. Okay, so the environmental assessment process typically follows a structured approach. So there are four distinct stages. There's screening. So the initial stage determines whether full-fledged environmental assessment is necessary for a project. Potentially, you'll see this even, at the small scale level of like housing developments. Well, actually not housing developments, but actually changes to your own house, with working with council, changing your local environment. This is where this initial screening becomes important, whether you actually need full-fledged environmental assessments for proposed projects. The decision is based on the potential impact and obviously scale of impact, and the level of regulatory requirements which can differ through the different levels of government, so from local government to state to federal government as well. The next stage is scoping. If an environmental assessment is deemed necessary, this scoping stage identifies the key environmental issues that need to be addressed in the assessment. So this will be consultation with stakeholders, experts, government agencies, and the public to determine the scope and focus of the assessment. Then you have the impact assessment. This stage forms the core of the environmental assessment process. It involves predicting and evaluating the potential environmental impacts of the proposed project on the environmental components, which we all know and love now. We'll get to know it: air, water, soil, and biodiversity. This evaluation typically utilizes scientific methods, modelling tools, expert knowledge, and drawing on resources and prior knowledge of the area as well. Then we have mitigation and monitoring. The final stage focuses on developing strategies to minimise or mitigate the identified negative impacts that the proposed development or activity will have negative environmental impacts on the project. So we need to mitigate or minimise those. Additionally, this stage establishes a monitoring plan to track the actual environmental effects of the project after implementation and ensure compliance with the mitigation measures. So this is the point where you get the go-ahead, but you have very strict monitoring that needs to be done to ensure that the industry is complying with those environmental guidelines. Okay, so environmental assessment offers a multitude of benefits for both environment and obviously society as a whole. By conducting a thorough environmental assessment, we can achieve the following. We can reduce environmental impacts by identifying and evaluating potential consequences beforehand. We can implement mitigation strategies and minimise the negative effects of the proposed development on the impacts of the environment. Informed decision-making. Yes, so sometimes decision-making isn't done, even though it is informed, but good decision-making isn't done even though it is informed. But environmental assessments provide valuable information for decision-makers, allowing them to consider environmental implications of projects alongside other factors. So there's obviously other factors that potentially over the top of this, including societal or cultural, as well as economic factors as well before making a final decision. Enhance public participation and transparency. We put this low, but it actually is probably more important than anything else, or as important. Environmental assessments will and should often involve public consultation and information sharing, and promoting transparency and allowing public to voice their concerns and participate in the decision-making process. The decision-making process is making decisions in their local environment, so they are stakeholders in that local environment as well. And lastly, we'll say the encouragement of sustainable development practices. So by integrating environmental considerations in the planning stages of projects, environmental assessments should encourage the adoption of sustainable development practices that prioritise long-term environmental and social well-being. We probably can think of, and maybe when we finish this, we can think about our own examples where we've seen things, developments go in and you think, don't think that's the most sustainable way or going forward as well. So, and we see this, and we can talk about, some developments in Western Sydney where we've seen, I guess, potentially what should have been identified beforehand, retrospectively now, retrospectively being implemented into developments or future developments because of what we've learnt about some of the developments that have gone into Western Sydney. Okay, so there are challenges. So while environmental assessments offer significant benefits, they face several challenges that we need to acknowledge and address as well. So it's the complexity of these issues often requires expertise in various scientific fields, like ecology, hydrology, engineering, to make assessments, to make the assessment processes, which makes them demanding and resource intensive as well. And often these drag on for a very, very long time. Furthermore, gathering accurate and sufficient data for the assessment is challenging and costly. Data availability or data accessibility is certainly a big thing. Limitations of scientific knowledge and capabilities of modelling tools can actually increase uncertainties in the assessment process. Engaging stakeholders and balancing their potential conflicting interests is also another challenge. So you've got stakeholders, you've got from industry, from the local communities, all having an interest and obviously all putting views forward. And so balancing that becomes really important. Project proponents might prioritise economic benefits, while environmental groups and local prioritise environmental protection and potential social impact. So you have to balance that. Ensuring objectivity and transparency is crucial, but we often see with these decisions, political decisions, usually made by the minister themselves, not just the department that assesses these, provides the reports. It all can come down to one minister signing something off. And acknowledging these challenges is actually very important. Actually, that yes, there is uncertainty, and actually quantifying that level of uncertainty becomes really, really important as we move forward, because then assessments and implementing the right type of assessments to then learn from and then or do real-time management becomes really important as well. So, but environmental assessment is what we've got, and it all, to a large extent, starts with the environmental impact assessments, which for a lot of you, if you particularly go down in consultancy path, we'll be doing a lot of these environmental impact assessments. And you will see the limitations. So we have a lot of students who go into this field, and a lot of them are making a difference, but a lot of them just get burnt out because they feel that they can't, over much, a very, very small time period, potentially not even on site doing a lot of these assessments, but using, databases and that sort of thing. It can potentially be soul destroying to some degree, because you are seeing, from your assessments either being ignored or not. As a consultant, you're only one part of that assessment, and potentially could be a small part of that assessment going forward, because of all these other factors that are in there that ultimately get decided by a minister or local government authority. Okay, the future. So the field of environmental monitoring and assessment is evolving. And like I said at the beginning of this lecture, like right at the beginning, there are things that we are, potentially, this unit is evolving and evolving in real time too. So it's continuously evolving. It's driven by advancements in technology. That's the big one. So technology is making things more accurate and potentially better to make informed decisions. And there's a growing recognition of the urgency of addressing environmental challenges. So key trends I will take in that we want to chat about now, and that we'll not just chat, but we'll delve into throughout this unit. Advances in technology, the emergence of remote sensing, artificial intelligence, big data analytics holds immense potential for environmental monitoring and assessment. These technologies offer greater accuracy, efficiency, real-time data monitoring capabilities as well. So allowing for more comprehensive dynamic environmental monitoring. So there's also increased focus on real-time monitoring. So this is where we're getting to, so we can actually understand what's happening in real time and make decisions in real time as well. So as technology advances, the ability to collect and analyze environmental data in real time will become increasingly more common. And the shift towards real-time monitoring will enable faster response times. More proactive strategies can be implemented as well. Integration with decision-making processes. So environmental data will no longer be viewed in isolation, but be seamlessly integrated into decision-making processes from local communities to national governments and international organisations. This is important. So this will ensure that environmental considerations are effectively incorporated into planning, policy development, and resource management practices. It's a holistic view. We can take data, real-time data from anywhere, and then process it in real time to make, I guess, better and more calculated decisions as we go forward. The other thing too, as I say, technology is improving. The importance of citizen science and public participation. People will become stakeholders, but they can actually become part of the process. I don't know how old you guys are, but even back in probably pre-2008, when the iPhone came along, right now everybody has around the world. So from the cheapest Android to the most sophisticated iPhone. Everyone has a computer, a GPS, a camera to take photos, apps, and a whole range of sensors on phones that can do, a whole range of different monitoring, like, LiDAR monitoring, radars that are actually, incorporated in the phones and that sort of thing now. So citizen science initiatives, which engage in the public by collecting and analysing environmental data are gaining momentum. Citizen science used to be kind of laughed at because, well, before we had, a phone that could capture data and quality data, kind of relied on people's reports, and we can judge how good people are at reporting things. I think there's still that. No one's still seen the Blue Mountains on the Nepean Black Panther yet. So, but those kind of things were like, hey, I've seen a panther. It's like, okay, they've got photo evidence, those sort of things. So, but we can now. If it's there, people can capture it, and people, along with other technology that's evolving, citizen science is one that will be very important, because I say that as well. It's not just about the data capture. It's actually, people are actually part of the process in their local communities. They'll actually become stakeholders in the data and the assessments, and become more connected with their local environments too. So that becomes really important in the decision-making process as well. Additionally, public participation is crucial for fostering environmental awareness, promoting community engagement, and ensuring transparency and accountability of these processes as well. So if people care and they're part of the process, we'll certainly get better outcomes in local community environments as well. Okie doke. So this will be the last slide for today, and then potentially we can talk a bit more and discuss the unit, but also discuss any of these issues that we talk about in terms of development and developmental processes. I'd love to hear case studies you've seen, or things that you've seen in your local environment, and you think, hey, that's not done right, or it could be done a better way. So in conclusion for this lecture, environmental monitoring and assessment are indispensable roles in safeguarding the health of our planet and local people and the local communities. These practices provide us with data and insights necessary to understand the current state of our environment, identify challenges in environmental issues, and make informed decision-making for sustainability and a sustainable future. So as we are seeing and we hear about environmental challenges, it's really important that we continuously improve, innovate in the field of monitoring and assessment, embracing new technologies, and fostering collaboration and integrating environmental issues into all aspects of decision making. So the idea then is that we can, ultimately achieve environmental sustainability. I'm going to stop there. So this gives you an overview of kind of, I think the key takeaways for this is, we talk about air, water, biodiversity, soils as the major parameters that we use, but we also, the important here is being data in those areas are then brought together to evaluate and make assessments, and then actually predict, potentially what impacts development or activities, in various areas will actually have. That's the process. Taking data, good data, accurate data, to make informed decision-making going forward. So I'll stop sharing here. You guys got any questions? Or something that you've seen that you want to, highlight in your local areas? So any of you guys in the southwest or northwest of Sydney living there? Jump in. Because I think there's certainly one that I think we could have predicted quite easily what we've seen in northwest and southwest. What do you think that might be in terms of developments going forward? The new developments that you see. What are some things that you look at those new developments and you go, why would they do that? No? Oh, hang on. There we go. Yeah, someone said black roofs. Airports? Yep. I like the black roof one. You just think, hang on. We've just had, what was that, 2019, 50-degree days, and you think, yeah, remove all the trees and put black roofs. Yeah. So that actually, that's a perfect one, because retrospectively, new developments can't do that anymore. So they brought in those laws to do that. But you really do think that, I think we had enough knowledge to actually make those calls before that as well. Yeah, airport, that is an interesting one. I would say one of the things about that is that, the process now is that, we're not going to stop the airport. So we're at that point. But there is certainly a lack of transparency around environmental impacts statements and assessments. So that is certainly a big one, so that people, that the community engagement and in that process, it certainly hasn't been good as well. Everything, yes. Crappy restoration programs in woodlands. Yeah, absolutely. I think there's even stepping back broader, that we have discussions around the coal is cheap and that sort of stuff compared to other energy things. But if you can Google this, full cost of coal, because for a long time, and even now, you would even say that in terms of once they finish the coal mines and that rehabilitation pretty much stops within 5 years of them walking off the land. They're seeing massive impacts, and Ian's a great one to talk to. They're water leaching even 20 years later since they finished coal mines. Water through the cracks and into our catchments in the Blue Mountains is still a big issue, and that's from mines that potentially stopped 15, 20 years ago, but they don't have to do anything about it. So if you look at the full cost of coal, I think you'd be quite surprised about when their commitment stops straight, once they walk off the land as well. Yeah, I've worked in many reserve sites, and management programs are quite useless. Yep. There certainly is a bit to say about that. There are some, and there's a whole range. You'll see we'll be on site looking at the BCT, the biodiversity offset scheme that the university is now signed up to. It has some good points and some very bad points. Good points are lots of land can be locked up in perpetuity. The bad thing is the offset schemes, and we'll talk more about it later on in terms of you can cut down a whole suite of forests, and it doesn't have to be replicated exactly the same in terms of buying off credits and to offset it. Very different you can offset. If you want to do some work on coastal in Sydney and that sort of thing, in area, you can offset somewhere in the middle of the country, and it's a completely different environment. So they're the things we'll talk about that as well. Someone who's lived in Penrith whole life, watching them rip out all the trees has made everything insanely warmer. Yeah. There's lots of work done in Western Sydney in this space as well. We'll highlight some of that stuff around warming cities, those sort of things as well. Yeah, heat sources. Yes, Jordan Springs. Yeah, absolutely. It's we're kind of involved in that process. Yeah, pretty much what they've done is build over swamps. So put in landfill over swamps, and it was always going to move. And so if you don't know about Jordan Springs, Google it, about sinking. There's whole areas now that are going to have to be bought back by the developer because they can't build there. So lots of bad decision making there that went well beyond. It was highlighted. We know it was highlighted. We saw the submissions going forward, particularly around Jordan Springs, and the decision was still made beyond that. So that's what I mean in terms of parts of the process. Even though we have the best, you can predict what will happen, and you have the best data that will happen. It's not fully informed decision making can be well beyond the environmental aspect as well. Could I please bring up the water quality slide? Okay. Oh, now you're getting me getting into the territory of trying to show the right screen. Is that it? The problem is now when I share this, I can't see your chat. Or oh yes, I can just. Okay. Now, what did you? Not much here on this one, but it's really just to highlight it. Did you want me to do anything else about it? The slides are already up. So if you go, I can show you where they are. So I'll stop showing now and just quickly go to module 1. So week 1, and if you go down here, there they are. Just there. Do they? Replace last year's. I thought, oh, okay. It hasn't. Sorry. I thought I replaced, this was from last year. So yeah, it's a different, I've redone it completely. I'll fix that up. Download last year's if you like. It has a lot more of the data analysis stuff, I'm pretty sure. So you can use that as a, but yeah, no, sorry. When I went through this morning, I thought I said remove and replace, but I've made a mistake. But I know that was yeah, okay. That one I haven't. Yeah, my boo-boo. I'll put them up now. Stop sharing. Should I get out of preview? I'll do it while I'm here, so. Lecture, edit. Mark for removal. Games, lines. Yeah, there we go. Yeah. Sorry about that. It is up now. Give it a second. Yeah, sorry, I put the wrong one up. I downloaded last year's before I put that one up and selected the wrong file. So sorry about that. Definitely let me know, particularly if you're following through. Beforehand, I might just make some mistakes like that. So if I start a lecture and they're the wrong slides, just stop me and I'll make sure I put them up so you can go through at the same time. So yeah. Anything more in the chat? Yeah. Yeah, 2023 slides. Yeah, that was my fault. Sorry, Ronnie. But they should be up now. So let me know if they're not. Yeah, I'm glad you guys brought up the that was the one I was thinking straight away, the black roofs. That just shake my head every time I drive down particularly like Londonderry Road and driving out, Windsor Road and that sort of stuff. So all right, what else? Have you guys got any other questions? How to boil your house 101? Absolutely. Or how to increase your electricity consumption? Absolutely too. So have you got any other questions? Otherwise, I'm happy to call it a day, an early mark. Next week, we will be online again. Richard Thomas will be talking about soils, and he'll try and make soils as exciting as they can be. They're obviously very important process, but yes, everyone loves soils. Sorry about that. Soils are great. Yes. So he'll be talking about soil monitoring as well. So yes, absolutely. I'm going to do that. I love soils too. Hang on. There we go. Oh no, maybe I'll just put a ghost. Anything else? I'll do a 5, 4, 3, 2, 1 countdown. If anyone needs to stay and talk about individual stuff, hang online. I'll hang online for a few minutes, and we can go from there. So 5, 4, 3, 2, 1. See you next week.